Strategemist introduces a patented architecture for contextual intelligence, built on dynamic graph neural networks. This system models real-time data as evolving graph structures, where nodes and edges are embedded with multi-order tensors representing semantic, temporal, and structural context. Unlike static GNNs, Strategemist's method supports recursive topological reconfiguration. The graph rewires itself dynamically based on incoming data, using edge-centric attention, entropy analysis, and signal propagation history. Each message passing layer uses adaptive attention kernels to modulate influence between nodes, driven by evolving context. To capture global dependencies, the architecture integrates spectral methods such as Laplacian eigenmaps and Chebyshev polynomials. These allow efficient encoding of long-range interactions and subgraph hierarchies. Structural consistency is maintained through persistent homology, where topological invariants, such as cycles and critical junctions, are extracted as persistent barcodes and tracked over time. Strategemist incorporates contrastive anomaly detection using Mahalanobis distance and Gaussian field modeling within latent graph manifolds. Outliers are flagged based on statistically quantifiable deviation from contextual baselines. The system enables symbolic reasoning through a logic engine that overlays business rules, compliance constraints, or domain-specific policies directly onto the graph. This creates an explainable neuro-symbolic feedback loop, ensuring outputs are not only statistically valid but rule-conformant. Multimodal fusion is achieved through tensor alignment transformers that project text, time series, tabular, and geospatial data into a shared latent graph. This enables unified inference across heterogeneous domains. Architecturally, the system is optimized for GPU, TPU, edge deployment, using fractal graph compression and hierarchical cluster pruning to reduce memory overhead without loss of semantic resolution. Learning is governed by embedded reinforcement agents that adapt propagation depth, attention weights, and structural configurations to maximize downstream performance. Strategemist's claims encompass the construction, transformation, interpretation, and governance of contextual graph intelligence. Strategemist defines graphs not as data structures, but as living architectures of machine reasoning.